This is section 11.2, and today we're going to do techniques for evaluating limits, which really just means we're going to do limits by hand. So up until now, you've been using your calculator to table them or graph these limits, and now we're going to learn how to do the same kind of limits, but do them by hand. So the first one we're going to do is called the dividing out technique, which is pretty self-explanatory. We are going to attempt to divide out. Again, the first thing you always want to try is direct substitution. So if I took that -3 and plugged it in, I would get -3 plus 3, which is 0, which I can't have. I can't divide by 0. Which means there's an error there. If I were to graph it in my table, I'd see error. So we need to come up with something else to use, and one of the techniques we can use is called dividing out. So we have the limit as x approaches -3, and we're going to factor the top, and we're going to see what could possibly cancel or change so that we could figure out this limit. So on top, I'm going to get x plus 3. On the bottom, or I'm sorry, the other parenthesis is going to be x minus 2. And now I can cancel these two. I'm left with the limit as x approaches -3 of x minus 2. Now I can plug in, and when I plug in -3 minus 2, I get -5 for the limit. Next one is very similar to that, another dividing out technique. The difference is this time I have a cubed that I'm working with, which means that I can't factor it. Not many people know how to factor a cubed, but we're going to use a different trick called synthetic division from semester 1 in order to help us divide this one out. So plugging in a 1, I would get 0 over 0, which is a problem. So instead, we're going to attempt to divide this sucker out. With x minus 1 being on top, I bet that x minus 1 is one of the factors when I get done factoring this. I'm betting that because I need to be able to cancel something in order to change the whole makeup of this fraction so that I can plug in the 1. And right now, that is a source of my problem, is that if I plug a 1 in right now, I'm going to get a 0 on top and a 0 on the bottom. So I'm going to do some synthetic division off to the side. I'm going to take all the coefficients right here, 1, -1, 1, and -1. In the corner, we're going to put the thing we're dividing by, and we're trying to divide out or factor out this x minus 1, which means our 0 in the corner is a 1. Drop the first number down, multiply these two to come back up, add down, multiply, add, multiply, add. This guy's a remainder. We should end up with 0. We're not going to have any goofy dividing ones here. These are all going to work. We started out with an x cubed, so now this is x squared plus 0x plus 1. This is what we essentially just factored. But instead of you factoring by hand, which would be kind of tough on a cubed, we use synthetic division to help us factor it. So we knew that x minus 1 would be a factor, and the other factor is what we got out of our synthetic division. So now canceling, I can do the limit as x approaches 1 of 1 over x squared plus 1. Plugging in my 1, I end up with a half. Next one is called the rationalizing technique, which you've actually done quite a bit. It's anytime you have a square root and you're trying to get rid of the square root. Right now, if I were to plug in a 0, I would get 0 over 0, which is a big problem. And so we're going to do something called rationalizing, where we're going to multiply by the conjugate, which would be x plus 1 plus 1. So the conjugate is the exact same makeup, same thing, except you change the sign between the two terms. And whatever you do to the top, you got to do the bottom, so we have to have the same thing on the bottom. So the limit as x approaches 0. And what I'm going to do now is FOIL this out. So I have the square root of x plus 1 squared, because I have 2 of them. And then the cool thing about conjugates is when you're doing your FOIL, the outside and the inside are going to cancel each other. You're going to end up with a positive square root of x minus 1, and then you're going to end up with a negative square root of x plus 1, and they will cancel each other out. So when you are rationalizing, all you really need to do is first and then last. And -1 times +1 is -1. On the bottom, you're going to kind of just want to write the mess. I would not suggest distributing that x in there, because in a little bit we're going to be able to cancel, and it would be hard for you to see if something could cancel if you start distributing things together. So I got the limit as x approaches 0. Anytime you have a square and a square root, they cancel each other. So I have x plus 1 minus 1. And now you can see that the 1 and the 1 will cancel. I have a plus 1 and a minus 1. Also, the x's will cancel. So I'm left with the limit as x approaches 0 of 1 over, squeeze this in here, and now I can plug in a 0. So 0 plus 1 is 1. Square root of 1 is 1. And 1 plus 1 is 2. Last one we have is our fraction ones, where even though I say fraction fun, they don't usually end up turning out that way for students, because we have fractions on top of fractions, which is kind of tricky to deal with. This one is also pretty tricky to put in your calculator correctly the first time, when you're trying to graph it. So plugging in a 2, we'd come into some problems right away because there's a 0 on the bottom. So we're going to have the limit as x approaches 2. And I'm going to keep this main divide sign right there. I'm going to keep my x minus 2 on the bottom. And for now, I'm just going to play with the top. And the top has two fractions that are trying to subtract together. And for me to do that, I would have to have a common denominator, which I'm about to make. The easiest way to find a common denominator is just to multiply. If you were going to add together 1/5 and 1/6, your common denominator most kids would come up with is 30. The fastest way to a common denominator is just to multiply, which is what we did. The second part of adding fractions is whatever you, or however you changed a denominator, like multiplying by 6 to get to 30, you also have to do that to the top. So the 1 would get multiplied by 6. We're going to have to do the same thing here. So just looking at this denominator, which is x plus 2, in order to change it into this denominator, it would need the 4. So I'm going to put a 4 on top, and then minus. This denominator had a 4, but it was missing that whole x plus 2. So that is what is going to have to go on top. So continuing along here, I'm just going to distribute the negative on the very top fraction. So 4 minus x minus 2. Again, I'm not going to distribute this 4 because I think when you are trying to cancel things, it's harder to see what's going to cancel when you have everybody foiled into one another. So kind of leave things separate if you can. X is still approaching 2. I'm just going to add like terms up here. So I've got a negative x and then plus 2. I've got a negative x right here and then 4 minus 2.
Hello, Cougars. It is 3:15 and all students need to exit the building unless you're in an after-school activity or working with a staff member. Thank you and have a great day.
Have a great day, everybody. So just putting together like terms, 4 minus 2 is 2, and I got the negative x right there. When you have fractions on top of fractions, like a third over 5/6, what you have to do eventually is flip the bottom and bring it up so that you can work with just a one-level fraction, and that's what we're about to do. So this x minus 2 is really over a 1, and we're going to flip it and bring it up to the top. So kind of coming right here, I'm going to do the limit as x approaches 2. I have a negative x plus 2 over 4 x plus 2, and then I have the thing I just brought up, which is x minus 2. And so still at this stage, if you were to plug in a 2, you would be in trouble because this is going to end up being a 0, and that's a problem. And you don't really have anything you can cancel yet. I mean, this is pretty close. I got the plus 2, I got the x, but I got this minus right here. So what I'm going to do is attempt to take that minus off and see what happens. Kind of like taking, if I had like 5x plus 10, if I took a 5 out and had x plus 2, we're just going to take a negative 1 out. So if I take a negative 1 out, I'll have x minus 2. And now I just found something I can cancel. So I'm left with the limit as x approaches 2 of a negative 1 over 4 x plus 2. And now I don't have any problem plugging a 2 in right there. 2 plus 2 is 4 times 4 is 16. So negative 16th is where we're at on that one. When you go to do the homework on this one, make sure that you are following your notes exactly. All of the fraction ones have the same pattern to them of how they go. The rationalizing ones have the same pattern. You'll FOIL things out. Lots of stuff will cancel. Synthetic dividing, they again have the same pattern. You synthetically divide, you'll be able to cancel. And dividing out, this one you're just factoring and then canceling out what you can so you can plug in the x value.